So my name is Aman Singh. I'm the student of CS5. So my topic is Google Big Table. So let's start. So topic are in Google Big Table. Why Google Big Table? What is Google Big Table? What are the key features of Google Big Table? Architecture, data model, and use cases. So Google Big Table. Google Big Table is a powerful distributed and scalable NoSQL database solution that is particularly suited with for massive scale applications. Here's why organizations might choose Bigtable, summarized in bullet points. So first point is high scalability, capable of scaling horizontally to handle petabytes of data and millions of read and write per second. High consistency offers strong consistency, ensuring data reliability, fully managed, reduces operational complexity with automated scaling, monitoring, and patching. Open source compatibility. API is compatible with HBase, enabling integration with existing open source projects. Cost effectiveness. Pay as you go. Pricing for storage and operation with fine grained bill. So now key feature of Bigtable. So first point is strong consistency. Bigtable guarantees strong consistency for reads and writes, ensuring data integrity and reliability. Second point is high availability. The distributed architecture ensures high availability, minimizing downtime and data loss. Third is scalability. Bigtable can scale horizontally to accommodate massive datasets and high traffic volumes. Fourth point is low latency. Bigtable provides low latency for reads and writes, enabling real-time data processing and analysis. This is the data model and schemas design. First is rows. Bigtable organizes data into rows, which are identified by a unique row key. Second is columns. Each row has a set of columns which are grouped into column families. Third is cells. Each cell contains a value associated with a specific row and column. Fourth is timestamps. Each cell stores a timestamp, allowing for versioning and time-based data access. Now distributed architecture. First is clusters. Bigtable is organized into clusters, each containing multiple servers. Second is servers. Servers are responsible for storing and processing data, providing high availability. Third is data replication. Data is replicated across multiple servers, ensuring fault tolerance and consistency. Scalability and performance. So rows. Bigtable can handle billions of rows, enabling the storage of massive data sets. 10K writes per second. High writes throughput ensures efficient data ingestion and update. 1 million reads per second. Low read latency enables real-time data access and analytics. So use cases and applications. Web analytics, analyzing website traffic pattern and user behavior. Second, financial data, storing and analyzing financial transaction and market data. Third is IoT data, managing and analyzing data from connected devices. Fourth is social media, storing and analyzing user profile interaction and content. So challenges and consideration. First is complexity. Managing a distributed system can be a challenging and requires specialized skills. Second is schema flexibility. Bigtable schema design require careful consideration to ensure data integrity and performance. Third, data consistency. Maintaining data consistency across the distributed system can be a complex. So, what are the key features? Columnar data model. Store data in a column oriented format which is efficient for handling wide and sparse dataset. Distributed architecture. Built on Google proprietary infrastructure, it allows horizontal scaling across many servers. high throughput, capable of handling billions of read and writes per second, a strong consistency, ensure reliable data operation with a strong consistency guarantee. Managed service reduces operational overhead by handling tasks like scaling, patching, and monitoring automatically. Now, what are the key integration? Bigtable integrate seamlessly with other Google Cloud services such as BigQuery for advanced analytics, Dataflow for real-time and batch processing, artificial intelligence and machine learning tool for building intelligent apps. Now, what are the key integration? Bigtable integrate seamlessly with other Google Cloud services such as BigQuery for advanced analytics, Dataflow for real-time and batch processing, artificial intelligence and machine learning tool for building intelligent applications. Now, what are the architecture? First, client library. Provide an interface for application to interact with big tables. Handles data reads, writes, and metadata operation. Manages connection to underlying big table infrastructure. Tablet servers. Tablet servers are the core data processing unit. Each server manages a subset of data known as tablets, which are contiguous ranges of rows in table. Master server oversees the overall system, assigns tablets to tablet server, monitors the health of tablet server, and reassign tablet in case of server failure. Now data models, tables, organized into rows and columns similar to a relational database but with a schemas-less column design. Rows, identified by unique row key. All data in a row is stored together for fast access. Column families, groups of columns that define how data is stored. Example, compression and TTL settings. Now, storage layer. Bigtable relies on Google Distributed File System for persistent data storage. Data is stored as immutable table file for efficient lookups and appends. Support data reapplication for fault tolerance and availability. Now distributed coordination. Manages metadata and ensure consistency. Facilitate leader election, server discovery, and log management. Provide synchronization among components. Now, what are the data models? The data model of a Google Bigtable is designed to handle large-scale, sparse, and distributed dataset. It provides a flexible, schema-less structure suitable for NoSQL database. Here are key elements of Bigtable data model. Tables. Data is organized into tables consisting of rows and columns. Each table can store a massive amount of data and is partitioned across multiple servers for scalability. Rows. Each row in a table is identified by a unique row key. All the data for a given row is stored together, enabling fast access. Column families. Column families are grouped together of columns that share common configuration like compression of TTL. Each column family is stored as a separate unit on disk. Cells. The intersection of a rows and column in a cell. A cell can hold multiple versions of data indexed by a timestamp. Timestamps. Timestamps are used to store multiple versions of cells data. They can be either system generated or applications defined. Data types. Big tables store data as uninterpreted binary string. It does not enforce a specific data type for stored values, applications, and are responsible for interpreting the data. Sparse data. Bigtable excels at handling sparse dataset because empty cells consume no storage. This design allows for flexibility in schemas, design and efficient use of storage, indexing and querying. The primary index is the row key. Bigtable does not natively support secondary indexes or complex queries. Queries are typically done using exact row key or range scan based on the row key. So here are a conceptual example of a big table schema for an IoT sensor data table. Now what are the use cases of Google Bigtable? So IoT data, storing and analyzing telemetry data from connected devices, time series data, application like monitoring financial data, analysis or stock trading system, personalization and recommendation, building recommendation system for e-commerce or streaming platforms, fraud detection, real-time data analysis for detecting anomalies or suspicious patterns, geospatial applications, storing location-based data for maps, logistics, and transportation. So that's all for Google Bigtable. Thank you.